First of all, we'll have to finish LC oscillations, then EM waves, and then AC circuits. Three things need to be done yet. There is no resistance in this particular circuit. If there is no resistance, there will be no heat loss. If there is no heat loss, what you have initially as electrostatic energy will be converted into magnetic energy as this will start decaying. As the capacitor starts decaying, it will be getting converted into current. It will be getting converted into current. If it is getting converted into current, half CV square will start getting converted into half Li square. Half Li square will again get reconverted into half CV square, and the process continues. Hence we will call this LC oscillation. Nowadays everything is replaced with solid state electronic devices, but once upon a time there used to be something called a ding dong bell, a very heavy bell. The calling bell used to, once you press it, it will oscillate for nearly 1 minute. Because of damped oscillation, it will die down. Now when you write the equation for this, L di by dt, right, plus Q by C will be equal to 0. In the direction of current, you are touching plus, I applied KVL, minus, hence plus. But you write L d2q by dt square is equal to minus 1 by C into q. d2q by dt square is minus 1 by LC into q. Right? Omega is 1 by root LC. Q will be equal to q naught cos omega t. Till now you are playing the other way around. Whenever you had this equation of SHM, you used to take Q equal to Q naught sin omega t. Today all of a sudden you are changing it to cos. Why? Because I am starting with charge on the capacitor. At time t equal to 0 I have got charge. So at time t equal to 0 I want Q naught. I don't want 0. I am not starting with current here. Hence Q equal to Q naught cos omega t is the solution for this. Value of omega will be 1 by root LC. What will I be equal to? dq by dt. Q naught omega sin of omega t. Obviously with a negative sign. Q naught omega is root LC sin of omega t. At time t equal to 0, Q is maximum. At time t equal to t by 2, I will do the comparison, take it down till here. Yeah.
Sir, should there be minus L di by dt?
Minus L di by dt will exist. One, the second time when I am replacing di by dt with dq by dt, when I am replacing I with dq by dt, the charge is decreasing. Right? Put a negative sign here. Negative of negative will become positive because I is equal to minus dq by dt. Because the charge is decreasing, dq by dt is negative. 2 times negative, I will get back here positive.
Yes.
I just skipped that 2 times negative. This is L, this is positive, negative. This is at time t equal to 0, I will have Q is equal to Q naught cos omega t. At time t equal to t by 4. And here the current I will be 0 at time t equal to t by 0. At time t equal to t by 4, what will Q naught be equal to? Q naught cos omega is 2 pi by t. 2 pi by t, and this is t by 4. This t will go, this will become 0. So current I will be maximum. You can cross verify. I will actually be maximum when omega will be this. Right? Now at time t equal to t by 2. Q is equal to Q naught cos 2 pi by t into t by 2. Am I right? Now cos pi minus 1, this will be minus Q naught. This will be now positive, this will be negative. Current will be 0. By the way, you want to calculate the current in it is Q naught by root LC sine of omega is 2 pi by t into t by 4. T, this will be sine pi by 2 is 1, you will get maximum current is this. The remaining 3 I will leave it to you because I will be running short of space. How do they do the comparison for this with mechanical waves? They tell you that this is the equilibrium position. Here what is stored as Q naught square by 2c will be stored as half k x naught square here. They are comparing one conservative force with another conservative field. Electrostatic is conservative, spring force is conservative. You stretch it. Energy stored is half k x naught square, half cv square or q naught square by 2c. Then at time t equal to t by 4, it's passing through with a velocity of v. Its energy is half mv square. They are comparing kinetic energy with half L I maximum whole square, half m v maximum whole square. Velocity is being compared with current. Electrostatic energy converted into magnetic energy. Magnetic energy is reconverted into electrostatic energy. How? You are comparing that with t equal to t by 2. It will come till here. Here again it is half k x square. X naught square. The same thing. Here it is positive, here it is negative. But q naught square by 2c, whether you are squaring q naught square here or here, it doesn't matter for me, it will turn out to be positive. Same thing happens here. X naught, whether it is elongation or compression, turns out to be the same. You know how to draw the other two. This is for t by 2. Draw next one and that next at time t equal to t. That next it will come back till here, and then at time t it will come back till here. This is what they say as comparing this with mechanical oscillation. One capacitor is charged to Q naught, the other capacitor is uncharged. Now there is an inductor in between. You are closing the switch. Find the current on, find the charge on the uncharged capacitor when the inductor is maximum. See, when the current is maximum in it, when I is maximum, di by dt will be 0, implies L di by dt will be 0, implies at that instant if I have some negative and some positive charge, this will be small q charge, this will be capital Q naught minus small q. Capital Q naught minus small q by C. I am going in the clockwise, right? Minus q by C is equal to 0. To make my life simple, I have taken the same capacitors. They can give you different capacitors as well. Now once that's done, Q naught minus 2q by C is 0. Q naught is equal to 2q. Q is equal to Q naught by 2. If they give you C1, C to C, the ratio proportionally changes. Note, in a superconducting ring, note, in a superconducting ring, note, in a superconducting ring, the resistance is absolute zero. Resistance is absolute zero. Induced current will be EMF by resistance. This is zero. Implies induced current can be infinity. For a definite change in EMF, if there is a magnetic field, EMF will be d phi by dt. This will be A into dV by dt. If the magnetic field is changing at some particular rate, or keep it as d by dt, anything can be changing. This is finite, EMF is finite, R is zero, induced current will be sufficiently high, so very sufficiently high that it will oppose the cause. Induced current opposes the cause effectively or very efficiently. When both the conditions are met, that means it will be seen. Every other case it only opposes the cause, but it will not be successful in nullifying the cause. But here the current is so very large that it can nullify the cause. That implies flux will remain constant. This happens only in a superconducting ring. And because flux will remain a constant, the induced EMF will become zero. And hence 0 by 0 is an indeterministic quantity. So this is the problem you will face with a superconducting ring. It opposes the cause very effectively. Hence flux will remain constant. If flux remains constant, EMF will become 0. EMF becomes 0. 0 by 0 is indeterministic, which cannot be determined, should not be defined. So they can ask you questions like, is the flux constant in a superconducting ring? The answer is yes. Is the EMF 0 in a superconducting ring? The answer is yes. And hence induced EMF will be 0. Hence induced EMF will be 0.
Yes.
Now when you speak about a transformer, write down the definition of a transformer. It is an electrical device which is used to convert high potential to low potential and vice versa, which is used to convert high potential to low potential and vice versa. Full stop. It is based on the principle of mutual inductance. It is based on the principle of mutual inductance. Don't forget the negative sign. This will be minus N1 into d by dt of BA. Now when it comes to phi 2, this will be called primary. This will be called secondary. Phi 2 is equal to N2 BA. E2 is equal to minus d phi 2 by dt minus N2 d by dt of BA. So E2 by E1 is N2 by N1. If N2 is greater than N1, this is a step up transformer. If N2 is less than N1, it will be a step down transformer. Step down will bring down the voltage. Step up will take up the voltage, will increase the voltage. This is a very standard question for you people in your intermediate board, HSC board. Present it exactly the same way. Please write that this is a soft iron core. Soft iron core. How did you assume this BA here and BA here to be the same, primary and secondary? Because the soft iron core will keep all the magnetic lines of force inside. Soft iron core is a very good paramagnetic material. It attracts the magnetic lines of force. So it will keep all of the flux inside. The only difference between the two is N1 turns here and N2 turns here. You want to increase the voltage here, let the number of turns here be greater than the number of turns. You want to decrease the voltage here, let the number of turns here be lesser than the number of turns here.
Sir, sir, is any dielectric used in the transformer?
No, dielectric why will I use? Electrical conductivity will go down if I use a dielectric. We will not use a dielectric. listen. Eddy currents. Unwanted currents are eddy currents. Now this is a circular loop. This is a circular plate. Now in a circular plate, if I have one region exposed to a magnetic field this way and this is oscillating, there is a solenoid which is kept this way and magnetic lines of force are intercepted here. If this is moving in this direction, velocity, the force on the positive charge in this region, FBI, will be upwards. Right? As this is moving this way, FBI, the particles here will start moving upwards. The particles here will start moving upwards. But here the density of the already existing positive charge will not permit the movement. See, if positive charge moves upwards, negative charge moves downwards. Now once the negative charge moves downwards, the already existing electrons here will be repelling the negative charge. So now they will try to come back to their original place. The electrons, after going out because of the magnetic force, will try to come back to their original place. What will be directing the electron to come back? The density of the electrons here, already existing density, will push the electron in its path. So the electron will complete the circle. This is unwanted current in the metal which will produce enormous heat. Hence, to avoid eddy currents, what do? Is they will take metal plates like this. If there are time varying magnetic fields, metal plates with many number of grooves in it. So that the path of the electron is destroyed. Now if you people recollect, in the microwave oven, the metal grill which is given on which you can keep any item, how much of a groove it will have? Microwave oven ke andar, the metallic grill that you keep, just recollect the number of grooves it will have. It will be something circular with thin metal here and such a huge groove. Thin metal and a groove. The grill in the microwave oven. If you people have not observed, go home and observe it today. This will be a gap and gap. Now you have destroyed the path of the electron and hence eddy currents can be avoided. Take down the diagram that explains everything in eddy currents. This is a solenoid. I'll keep it this way. So solenoid ka bahar we have calculated magnetic field. If you people recollect, we calculated magnetic field along the axis of the solenoid. We did this while comparing a bar magnet with a solenoid. Right? So solenoid is kept this way, the magnetic lines of force are inwards. So when this is moving, the force on the positive charge will be upwards, force on the negative charge will be downwards. FBI. This is a metal plate, circular metal plate. I kept a marker type solenoid here. Magnetic lines of force here are intercepting the metal perpendicularly inwards. Positive charge will experience a force upwards, negative charge will experience a force downwards. Right? This will keep turning in this particular direction. The negative charge which comes over here, it will be repelled by the already existing negative charge density here. So the particle coming here, because of the excess density here, will be pushed this way. So it need not be perfectly circular, it can even be an arbitrary shape. It can be a shape like this, it can be a shape like this. It will come back to its path, it will be guided into the path in which the density of the electrons should come back to normalcy.
Yes, sir.
Now listen. Maxwell's relations. First is Gauss law for electrodynamics. This will be Q by epsilon naught. Gauss law for magnetostatics will be 0. Ampere's law B dot dl is mu naught I is the third equation, which will go a correction for right now. Closed integral E dot dl is minus d phi by dt. Faraday's law. Gauss law for electric fields, Gauss law for magnetic fields, Ampere's law and Faraday's law. We have a strange problem with Ampere's law. What is the problem that you will be facing? Why should it need a correction? What is the correction that you will be doing? The correction is like this. If you have closed integral B dot dl, you told me mu naught I is the net current passing through the Amperean circulation. Neither did you people get the doubt, nor did I answer a particular question. Should the area through which current pass be subtended by this particular wire? Yes. Till date. That area could as well be even outside. It could be like this. It's like telling you this is a circular Amperean circulation and I have current passing through it. But the surface through which current is passing need not be in the plane of the loop. The surface could as well be this. Right? The area through which current is passing need not be in the same plane as that of the Amperean circulation. This is the Amperean circulation. You did not tell me this while dealing with Ampere's law. Yes, we did. The information was unnecessary then. It's like take a ring, put it in a soap solution. Pick up the ring. There will be a soap bubble in the plane of the ring. Now blow air. the balloon will bulge outwards. Now this current carrying wire should either be passing through this surface or this surface. Either of the surfaces ampere is okay. Integral B dot dl along this will be mu naught I. Till now you used to consider only this surface in the plane of the ring, in the plane of the ampere circulation. Ampere did not give you any such restriction. This can as well be your surface. So what is the problem here? I'll explain the problem, take it down till here. Okay. Now because of this correction in Ampere's law, we find a strange problem. What are you telling me now? You are telling me that the area through which the current is passing need not be in the plane of the Ampere circulation. I repeat, area through which current is passing. Write a note on it. Note, area through which current is passing need not be, area through which current is passing need not be in the plane of the Ampere circulation. Need not be in the plane of the Ampere circulation. Now if there is current passing through it, you have got plus Q and you have got minus Q here. Agreed? Now till now we used to consider an Ampere circulation like this, and we used to tell you closed integral B dot dl is equal to mu naught I. Here the area through which current is passing is in the plane of the Ampere circulation. A circular ring, the area through which current is passing is in the plane of the Ampere circulation. What if I consider an area like this, like an earthen pot? Take the rim of the earthen pot as the Ampere circulation. Area through which current is passing through be the earthen pot. NCERT textbook gives you a tiffin box. These are the two capacitor plates. It says this is a tiffin box. The rim of the tiffin box is the Ampere circulation. Area through which current should pass is the tiffin box. Here for us is the earthen pot. For this, closed integral B dot dl will be 0. B dot dl along the same line integral. This is a surface, earthen pot. The current passing through this will be 0. Current passing through a capacitor is 0. Now this is contradicting closed integral B dot dl for this. Using this surface I am getting this. Same closed integral B dot dl for this. Using this surface I am getting 0. The same thing here. So they said there should be some correction to be done here. If there is some correction that ought to be done, the proposal that Maxwell gave is, science is sometimes very funny. They have no proof. They will predict few things because there is a necessity for that. Momentum could not be conserved in beta decay. They proposed a particle called a neutrino. Did you observe a neutrino? No. Did you see a neutrino? No. Why did you predict it? My necessity. I have a necessity. Their momentum should be conserved. So predict a particle. Who will discover it? Whoever has the taste for working on it will work on it. They fit. Right. Today I need a particle to conserve momentum for that equation. I predicted a neutrino. Beta capture antineutrino. Here, did you see the particle? I haven't seen the particle. Then why are you proposing it? Because I have a necessity. Nature likes symmetry. No, हद हो गई है यार. इसमें तो wave observes particle nature. So particle also will have wave nature. तूने observe किया नहीं. Then why did you propose? Because nature loves symmetry. Do you have a proof for it? No. Nature loves symmetry. My wish. Here also the same situation. First of all, nature loves symmetry. Why does nature love symmetry? That's none of your business. Nature loves symmetry. Love is blind. It has no reason. So they said, time varying magnetic field produces an electric field. You told me in the last chapter with proof and we accepted. So now I tell you vice versa. Time varying electric field will produce a magnetic field. Here as the current is passing, the electric field is increasing. Time varying electric field produces a magnetic field. Did you experimentally observe? No. Do you have any proof for it? No. Why are you proposing it? To satisfy this relation. This is a fundamental relation. What makes you confident that your assumption will be right? Nature loves symmetry makes me confident. Right? So here, till now we were under the feeling that only current will produce a magnetic field. That is what is Ampere's law. Now he is telling us not just current, a time varying electric field also will produce a magnetic field. Now the actual proof of this is beyond your scope. But then they will give you the answer. How do you want me to make a guess with the answer? NCERT textbook did a very good job with this. NCERT, they made you make a guess as to what that value will be. How did they make you make a guess? Electric field is Q by A epsilon naught. Flux due to electric field is E dot A. This is Q by epsilon naught. Q is epsilon naught phi. dq by dt will technically be the current here. This is epsilon naught d phi by dt. Whatever is the magnetic field produced by this dq by dt, a similar and same magnetic field will be produced by epsilon naught d phi by dt, where d phi by dt is the rate of change of electric flux. They said इस dq by dt के वजह से जितना भी magnetic field यहाँ produce हो रहा है, time varying electric field should produce the same magnetic field along the rim and it will not be zero. They made the correction. Integral b dot dl is mu naught I plus id. What is id? Displacement current. नामकरण भी बड़ा अजीब चीज है यार. You are telling me this is not current. Then why are you calling it current? Simply because I am already tuned with a mental block that only current produces magnetic field. Now I tell you something new you will not be able to accept, and dimensionally this will be equal to current. Hence they called this as a displacement current. Why current? Only because of my mental block that current is the only source which produces magnetic field. Hence, closed integral B dot dl is mu naught I plus epsilon naught d phi by dt. Now, cross verify this once again. If I am finding out integral B dot dl when there is current, two situations. When the capacitor is completely charged, there will be no current. There will be no current. So integral B dot dl then will be 0. Right? Even if I take this surface, it will be 0 then. Because for this surface, if the capacitor is completely charged, d phi by dt will be 0. Suppose if current is flowing, integral B dot dl is mu naught I. If I take this surface, when I take this surface, integral B dot dl will be mu naught id epsilon naught d phi by dt. Because here there is a time varying electric field, d phi by dt will exist. That into mu naught will give me integral B dot dl along this. And what is this equal to? dq by dt. dq by dt is equal to current I. Will I get back the original answer whether I take this surface or this surface? Is the prediction clear? Take it down. I will repeat this logic once again and then we will go ahead. Now listen, I explain whole of this again. You have two surfaces through which this current is passing. One is the surface in the plane of this loop, the other is this surface. Now there is no current passing through this surface is our problem. That's why you are getting integral B dot dl 0. This for sure will be wrong. What is happening? Here I have current, so this plane is giving me this answer. Now here I don't have current, but there is a time varying electric field which is producing the magnetic field. How much is that? Electric field will be Q by A epsilon naught. Flux due to the electric field will be this. Cross multiply and differentiate. dq by dt will be I. Its equivalent will be epsilon naught d phi by dt. That means the rate at which electric field intercepting this surface is varying is d phi by dt. So it will produce a current magnetic field. How much magnetic field? Mu naught I plus epsilon naught d phi by dt. This epsilon naught d phi by dt is called as displacement current. Is it really current? No. Why are you calling it current? Because we have a mental block in accepting that other than current something else can also produce a magnetic field. Now you can cross verify. When current is flowing, integral B dot dl along this will be mu naught I. Now here there is no epsilon naught d phi by dt, so you will get mu naught I only. But if I take integral B dot dl along this line, because of this surface, it will be integral B dot dl is mu naught into this. And what is this equal to? This is equal to dq by dt. What is dq by dt equal to? Current. So I will get the same value of mu naught I whether I take this surface or I take this surface. Is it clear till here? Today quite a few things will be a bit disturbing for you. Till now whatever we have learned will tell you, it's like telling you, while I teach Rutherford's model, I will tell you this is the complete truth. Then I will tell you, अरे यार ये सही नहीं, Bohr's atomic model is the complete truth. Then I'll tell you Bohr's atomic model में भी गलतियां हैं यार, quantum model is the complete truth, right? There we gave you time to digest Rutherford's atomic model, उसके बाद we gave you a lot of time to digest and then we told you something new. Here till now we used to tell you something, all of a sudden we will tell you no, that's wrong, this is right. So when we tell you in quick concessions, it will be difficult for you to digest, but then you will go through this pain today.
So produced magnetic field की direction क्या है?
I am coming to that. Now that you told me that in a capacitor plate you have a time varying magnetic field here, kindly tell me the value and its direction. Right? Now suppose I take the plate to be of radius A and I assume an ampere circulation of radius small r. Closed integral B dot dl is equal to mu naught I plus epsilon naught d phi by dt. Closed integral B dot dl is equal to mu naught, I is 0, there is no current. Epsilon naught d phi by dt will be this. Epsilon naught d phi by dt will be this. Right? Epsilon naught d phi by dt. B integral dl cos 0 is equal to mu naught epsilon naught d phi by dt will be pi r square dE by dt. B into 2 pi r will be mu naught epsilon naught pi r square dE by dt. Pi and pi, r and r. B is mu naught epsilon naught r by 2 into dE by dt. Direction, it will oppose the cause. If the electric field is increasing this way, magnetic field will be increasing this way so that it opposes the cause. If the electric field is increasing this way, magnetic field will be established in this direction so that it produces a varying magnetic field, produces an electric field in the opposite direction. Lenz's law is obeyed. Lenz's law is obeyed. Opposes the cause. What if I want the value outside the two parallel plates? This is positive charge, this is a negative charge. I want the value outside the two parallel plates. What if I want the value outside the two parallel plates? Have a look at it. Here is my requirement. Closed integral B dot dl is mu naught I plus epsilon naught d phi by dt. B integral dl cos 0 is mu naught epsilon naught d phi by dt. B 2 pi r will be what area of this ampere circulation is intercepted by the electric field? Pi a square dE by dt. See the difference properly. What area of this is intercepted by the electric field? Only pi a square. I will not take the complete area of the ampere circulation. B is equal to mu naught epsilon naught a square by 2r dE by dt. What if I want the magnetic field at the periphery? At the periphery. Periphery. R is equal to A. Put R equal to either here or here, you will get the same answer. At the periphery, R equal to A. That is the magnetic field at the periphery. End of today's class, we will need that formula. Please take it down. Your class notes is the only source where you will get these derivations. Please make a proper note. Yeah.
What if the plates of capacitor are not circular?
Absolutely no difference. You have taken circular symmetry to explain that. What if I take this amperance circulation non-circular? If the plate is not circular, I will take the amperance circulation also in the same structure as that other plate. So that won't affect my problem.
So may you please repeat the directions?
Lenz's law. If the electric field is increasing, here the magnetic field will be anti-clockwise. If the electric field is decreasing, magnetic field will be from this side clockwise. Opposes the cause. If the electric field here is increasing, magnetic field will be anti-clockwise. If the electric field is increasing, magnetic field will be anti-clockwise. Now listen to the most important derivation. Here we will play it very smart. No two textbooks will give you the same derivation. This is one more problem. But the easiest derivation is given in university physics. So obviously I will do the easiest derivation. But the easiest derivation may you will get a few doubts. Right? There is a small problem with this. We are deriving the speed of the electromagnetic wave. University physics is your reference point for this. How are you generating the wave pulse is once again beyond your scope. But this is the way an electromagnetic wave will be generated. If this is an electric field, this is a magnetic field, the electromagnetic wave will be propagating perpendicular to both. The electric field will be a sine curve like this, the magnetic field will be a sine curve like this. This will be the way an electric field is varying. This will be the way a magnetic field is varying. Varying electric field produces a magnetic field, varying magnetic field produces an electric field, and the electromagnetic energy is travelling along the x-axis. This is precisely what's happening. Now, what university physics did is, if I take a sine curve, doing the mathematics of that is very difficult. So what university physics did is, it took a planar wavefront. This is an electric field, this is a magnetic field, this is the electromagnetic wave. It took a planar wavefront. Planar wavefront, it's not a spherical or cylindrical or a sine wavefront. Planar wavefront, it's travelling this way. And then they said, assume an amperance circulation like this, PQRS. Assume an amperance circulation like this. This is A. They played it smart. They told you the wave travelled from here till here in time delta t. And they placed one part of the amperance circulation outside. And they placed one part of the amperance circulation outside the electromagnetic wave. Electromagnetic wave did not come till here. Right? Did you do this any time before? Yes, we have done this. While dealing with a solenoid, how did you calculate the magnetic field? You told me PQRS. You kept one part of the ampere in circulation outside the solenoid where the magnetic field don't exist. You are doing the same thing here. You keep one part of it outside the electromagnetic wave. Electromagnetic wave came only till here. Right? This is what is the smartness that university physics played with. What is the advantage of doing that? See what happens here. Closed integral E dot dl will be minus d phi by dt. Faraday's law. E dot dl along PQ. E dot dl P to Q plus E dot dl Q to R plus E dot dl R to S plus E dot dl S to P will be minus d phi by dt. Electric field here will be 0 because it's outside the electromagnetic wave. Q to R, electric field is perpendicular to Q to the line QR. So again it is 0. R to S, electric field will be E into A with a negative sign. A with a negative sign. R to S, electric field is upwards, length is downwards. E and dl are in opposite direction. S to P again it will be 0. I will be left with minus EA is equal to minus of d phi by dt. What flux are you speaking of? The magnetic flux. Magnetic flux. What area did it sweep? What area did it sweep? This area it swept. This area it swept. Are you able to see that? Wait a minute. I will redraw this again so that you get a proper feel of it. Giving it some space. Now observe this. They have taken PQRS like this. PQRS. This is the ampere in circulation. This breadth is A. That's what you have taken. Now E dot dl along this, E dot dl along this, E dot dl along this, E dot dl along this. What area did it sweep? This is the magnetic field perpendicularly outwards. What area did it sweep? It swept an area of magnetic field into A into C delta T divided by delta T. A into this distance is C delta T into this particular area. Area is A into C delta T, that into B, that is d phi by dt. Cancel this out, you will get E equal to CB. This is the general equation of an electromagnetic wave. What did you apply? Integral E dot dl is minus d phi by dt. What is d phi? This area which it swept in time dt. That into magnetic field will be d phi by dt. Problem is not yet over. Are you people able to see the right part of the board?
Yes, sir.
Okay. Now, problem is not yet over. Time varying magnetic field produced an electric field. Now, time varying electric field should produce a magnetic field. See what happens. Time varying magnetic field. Below this line, I will draw this line. Below this line, I will draw this line. And this will be PQRS now. PQRS. Anti-clockwise. Now closed integral B dot dl is equal to mu naught epsilon naught d phi by dt. Do you all agree with that? Current don't exist. This is time varying electric field. This is B dot dl P to Q plus B dot dl Q to R plus B dot dl R to S plus B dot dl S to P will be equal to d d phi by dt. Here the electric field is upwards. Electric field into A into C delta t divided by delta t multiplied with an epsilon naught. Now P to Q, you will understand that magnetic field is zero. Electromagnetic wave did not come till there. Q to R, B dot dl will be zero because they are perpendicular. R to S will be B into A. This will be zero because they are perpendicular. Now A and A will go delta t, delta will go epsilon naught EC. Equation 1, equation 2, if I summarize, what do I get? Epsilon naught CB into C. I forgot a mu naught here. And hence I will have B is equal to mu naught. B gets cancelled, C is under root mu naught epsilon naught. Speed of an electromagnetic wave pulse in vacuum is 3 into 10 to the power 8 meters per second is got from here. In a medium, what will you deal with? You will put this as mu r epsilon r. In a medium, this will be mu r epsilon r. Right? What did University of Physics do? Where did it play it smart? First of all, by assuming planar wavefront, it didn't have the requirement to integrate for area. Here, area became so very easy by assuming a planar wavefront instead of a sine curve. Right? Second, smartness that University of Physics played. It kept this outside the electromagnetic wave. So, integral E dot dl for P to Q and P to Q here, both will become zero. That makes your job much easier. These are the two smart moves that University of Physics has done. Traditionally, if you were to solve this problem, the most orthodox derivation is given in HCV. I will show you what is done. You will get a feel of it. But first take this down. Now listen. After seeing this derivation for some time, you people will get a doubt. You told me varying electric field gives me a magnetic field, varying magnetic field gives me an electric field. Here is this electric field and magnetic field constant values? They should be varying. If they are varying, in this particular area, you have taken a constant magnetic field. You have taken in this particular area a constant magnetic field. How reasonable are you? First you drew a sine curve. That means if I go to the right, if I consider this to be my ampere circulation, here and here the electric field need not be the same. The magnetic field need not be the same. Right? So very technically I should integrate that. Very technically I should be integrating that. Are you getting my point? This is what technically happens. Electric field is equal to E naught sine of omega t minus x by c. Magnetic field is equal to B naught sine of omega t minus x by c. Now I assume an ampere circulation like this. This is x1, this is x2. This is PQRS. This derivation is picked up from HCV. You can have a look at it. You don't need to write this. I am just doing it for your understanding of what was done by university physics that made the derivation small and a smart move. Now here PQRS, this is my ampere circulation, right? Closed integral E dot dl is equal to minus d phi by dt. I'll have to simplify LHS separately and RHS separately. LHS, this will be E naught. This length you have taken as A. This was your ampere circulation, right? This was your ampere circulation. This length you have taken as A. E naught into A, right? Sine of omega t minus x2 by c. A and electric field are in the same direction. Q to R will become 0. R to S will become minus E naught into A sine of omega t minus x1 by c. Here electric field is upwards, this is downwards. S to P will again be 0. S to P will again be 0. Is the logic clear till here? This is the LHS. Right? Now listen. For RHS, magnetic field is varying to the right. I consider an element dx at a distance of x. Here in this small element the magnetic field will be constant. For RHS, magnetic field will be, the flux will be, d phi will be B naught sine of omega t minus x by c into A dx. This I will have to first of all integrate from x1 to x2. Then I will get the total flux. Do you agree with that? Now this will become B naught integral of this cos omega t minus x by c. I will keep A outside. You are integrating with respect to x. That means upon minus omega by c x1 to x2. Is my integration correct? Keep an eye on the simplification. You are integrating with respect to x. So minus omega by c will come to the denominator. Minus of B naught AC by omega. Even integral sign will have a negative sign, no yaar? Integration of sine function will have a negative sign. Agreed. Keep an eye on the simplification when this is the way you people are keeping an eye. Right. I put integral sign as cos, you are saying yes. Don't you think it should have a negative sign? Negative, negative will go. Agreed. Now cos omega. Wonderful. Good. x2 by c minus cos omega t minus x1 by c. I substituted the upper limit minus the lower limit. This is the total flux. But for me to complete the simplification of the RHS, now I should differentiate the flux with respect to time. d phi by dt. Now when I differentiate B naught AC by omega, differentiation of cos will become sine minus of sine omega t minus x2 by c minus of, I kept the negative sign outside, sine omega t minus x1 by c. into omega, this complete into omega. I will remove this. Agreed? Because I differentiated with respect to time. Say something. Now equate LHS and RHS. See the LHS, see the RHS carefully. Am I getting E naught is equal to CB naught? Was this the first part of the derivation we did using even university physics ka derivation?
Yes, sir.
Now you understand how smart university physics played, that they avoided whole of the simplification. What they have taken is, they have considered this Amperian circulation to be this thin element, and one part of it they kept it outside. So x2 का सवाल आया ही नहीं. This expression itself they eliminated by keeping this outside the electromagnetic wave. But yet there is a small difference. University physics got E equal to CB. E and B are instantaneous values. If it is true for every instant, it will be true even for peak value. Other half of the derivation is given in HCV. I'll skip that. Now that you people have an understanding. What is the other half? You will take an Amperian circulation like this on this plane, XZ plane, just as we have done in the previous case. I assure you, you will get the answer. Derivation is given in HCV. You can have a look at it. This is also given in HCV. You can have a look at it. You don't need to write this. Can I rub the board? Now the most important thing here, Ponting vector. First of all, we speak about energy density. Till now, you have calculated energy stored in an electric field, energy stored in a magnetic field. Sorry. Energy stored in an electric field, energy stored in a magnetic field. Right? Now consider this. Net total energy density in an electromagnetic wave will be sum of electric field plus magnetic field. Now I know electromagnetic wave constitutes both electric and magnetic fields. Right? So this is the energy density. But you gave me E equal to CB as the electromagnetic wave. Half epsilon naught E square plus B is equal to E square by C square by 2 mu naught. Right? Half epsilon naught E square plus E square by 2 mu naught. C square here will be mu naught epsilon naught. Half epsilon naught E square plus half epsilon naught E square. Epsilon naught E square is the energy density of an electromagnetic wave. You converted magnetic field into electric field, so you got it this way. Sorry. If you convert a magnetic field into electric field into magnetic field, you will get B square. Take it down. Take it down, take it down. Energy density. I'll just be back in a second. Ponting vector. Firstly, This Ponting is a scientist. Secondly, he is from England, not from Australia. He defined energy per unit area per unit time perpendicular to the area. Perpendicular to the area. Energy per unit area per unit time perpendicular to the area. Because he defined the direction, it became a vector. If not, he is speaking about energy. This is electric field, magnetic field, and see. Right? Because he defined an area and he is telling you perpendicular to the area, this became a vector. If not, he is speaking about the total energy carried per unit area per unit time. This distance will be C delta T. This is the area. How much energy is being carried by the electromagnetic wave? Energy carried is epsilon naught E square into volume, because you calculated the energy density. Now, your requirement is U divided by A delta T. This is epsilon naught E square into volume is A into C into delta T. See if you are convinced. The volume covered area into this length. Denominator mein you will have A into delta T. Delta T, A will go. Magnitude of the Ponting vector is one electric field expression I will keep as it is. The another electric field expression will be CB from the electromagnetic wave. This is C into delta T has gone. Right? This will be epsilon naught EB. C square is mu naught epsilon naught. Ponting vector will turn out to be EB by mu naught. The vector will be E cross B upon mu naught. E cross B, you can see electromagnetic wave is going perpendicular to the direction of electric and magnetic field. So E cross B. So Ponting vector defined energy carried by the electromagnetic wave perpendicular to E and B both together to the plane containing E and B. This will be the direction in which the electromagnetic wave will travel. Few textbooks will give you Ponting vector as E naught cross B naught by 2 mu naught. Chinta mat karna yaar, this is electric and magnetic field instantaneous values. Instantaneous values implies you will be taking sine curve. E will be E naught sine omega t minus x by c. B will be B naught sine of omega t minus x by c. Sine square ka average will turn out to be half. So don't get worried seeing two different expressions in different textbooks. Iska interpretation is fatal and dangerous. Take it down, we'll deal with it. Now, till now we have been heat generated in a wire generated in a wire of resistance R. You have taken a resistance of length L and radius A. You have taken a resistance of length L and radius A. If I have V1 and V2 potential difference, E is equal to V1 minus V2 by L, you will have a current of I. You are under the impression till date that the heat generated is I square RT because of the current flowing through the wire. I repeat, you are under the impression that heat generated in the wire is because of the current flowing in the wire. I square R dt. This is what was told to you. But look at the beauty in it. Observe this carefully. If this is the resistor, current is flowing this way. That means the electric field is in the same direction. J equal to sigma E, Ohm's law. Electric field is in this direction. Magnetic field will be this way. I will take the topmost point on the surface. Electric field is this way. Magnetic field is this way. So E cross B. Am I getting perpendicular to the wire inwards? Your Ponting vector is E cross B. Electromagnetic wave will be carrying energy in the direction. Now let me take one more point to show you an example here. On the surface to the right, let me keep it here so that you are able to see. Electric field is this way. Magnetic field is this way. E cross B. Am I getting this? E cross B. E cross B. E cross B. Electric field is this way. Magnetic field is this way. E cross B. On the surface of the wire at every place you will get E cross B perpendicular to the wire. On the surface of the wire at every place you will get E cross B perpendicular to the wire. Right? How much is that? Your Ponting vector is U divided by A delta T. U divided by A delta T. Energy per unit area per unit time. If I take energy per unit time, this is Ponting vector into area. How much is Ponting vector? EB by mu naught into the curved surface area 2 pi AL into the curved surface area 2 pi AL. Electric field is V by L. Magnetic field mu naught I by 2 pi A. Magnetic field on the surface of the wire into 1 by mu naught into 2 pi AL. Right? Now mu naught 2 pi L 2 pi L. V is equal to IR. I square R is energy per unit time, which technically is the energy entering as electromagnetic wave into the wire. तो अब तक झूठ क्यों बोल रहे थे यार? करंट के वजह से हीट जनरेट हो रहा है सोच रहे थे हम. अब तक तो इलेक्ट्रोमैग्नेटिक वेव पढ़ा ही नहीं हम लोगों ने. तो यही तो बोलना पड़ेगा कि I square R is the root cause for heat. Understand one thing. If this is a wire, there are only two things that will exist: electric and magnetic field. Because of the electric field and the magnetic field, electromagnetic energy is entering into the wire at this rate. So the wire's temperature will rise depending on the specific heat capacity of the resistor, Ms delta theta. Because of the temperature rise, it will emit energy in accordance with Stephen's law, Ea sigma T to the power 4. Wire, battery will do work which will generate electromagnetic energy which will enter into the wire perpendicularly. Because of that electromagnetic energy, temperature of this wire will rise. Once the temperature rises, The wire will emit energy in accordance with Stephen's law, EA sigma T to the power 4, which will be equal to I square R. Because the wire resistor is not keeping any amount of heat with itself, it will have to emit whole of that energy. Strange, right? Something more disturbing is yet to come. Take it down. Now consider this. Energy stored in a capacitor. Till now you were under the impression that current was flowing through the capacitor. There was accumulation of positive and negative charges, and I had an electric field established here, and the energy stored per unit time will be half epsilon naught E square into volume, area of cross section, pi a square into d, this particular distance, d by dt of this, d by dt of this. This was according to the information that we have from electrostatics, which we have learnt. We learnt in electrostatics that this is the energy density, half epsilon naught E square. Volume in between the capacitor plates, pi a square d. D by dt of this will be u by delta t. This will be half epsilon naught pi a square d 2e dE by dt. This will turn out to be epsilon naught pi a square d E dE by dt. What does your electromagnetic theory say? Your electromagnetic theory says this is one plate here, there is another plate here, right? There is one plate here, another plate here. Electric field is downwards. Electric field is downwards. Magnetic field, in the starting of today's class we have taken circular curves. E cross B, E cross B, electric field is downwards. I put my four fingers on this, rotate them towards B. All throughout I will get E cross B perpendicularly inwards from the sides of the parallel plate capacitors. From the parallel plate capacitors, E will be from the upper plate to the lower plate. Magnetic field will be circular, E cross B, E cross B, E cross B, all throughout. E cross B will turn out to be in this direction. Pointing vector. Are you telling me the most weird thing? Energy in the form of electromagnetic form will enter into the capacitor from the sides. Yes. energy in the form of electromagnetic energy will enter into the capacitor through the sides. Yes. Prove it mathematically. This is my experimental observation. Electrostatic energy was only half epsilon naught E square. This is matching with experimental result. Now show me that your electromagnetic energy is giving me this amount of energy. Energy per unit time will be Ponting vector into area. Because Ponting vector is energy per unit time per unit area perpendicular to this curved surface area. Entering inside. This is EB by mu naught. Area is 2 pi A into D. The curved surface area will be length into breadth. Electric field, I'll keep it as it is. Magnetic field at the periphery, mu naught, epsilon naught, A by 2, dE by dt. You derived in today's class. 1 by mu naught, 2 pi A into D. Mu naught, 2 and 2. Epsilon naught, pi A square D. I have one pi here, one A here, one A here. Pi A square D E into dE by dt. You are telling me the most funniest thing that if current is flowing this way, the electric field this way and the magnetic field this way around the wire will be entering into the capacitor from the sides. Yes, in the form of electromagnetic energy. What is your fascination for this here? We are happy believing that current flows and it stores energy. It was a simple model. I am happy with that. Why are you confusing me at the end of the day? The complete truth is like this. Do you people recollect when we started with capacitors, we told you work done by the battery is delta U plus heat loss. This was half CV square and this was CV square. We told you this amount of energy must be lost in the form of heat. You have a resistor, you don't have a resistor, you are at it. You must be losing that amount of heat as half CV square. This is what you told me. Then the 79th problem of HCV in current electricity, you placed a resistor here and you integrated I square R dt and you showed to me this is half CV square. Yes or no? Now that if I have a resistor here, I was happy. I could account for the heat loss. What if I don't have a resistor? I didn't have an answer then. I didn't have an answer then. If I don't have a resistor, what will you do? Now I have answered it. That question itself is meaningless. How? When I have a battery and a capacitor and a resistor, battery did some work, half of that went into the resistor, the derivation before this. Half of that went into the capacitor from the sides. Half of that went into heat from the surroundings of the resistor. Now battery does the work. If the resistor don't exist, half the energy goes into the capacitor, balance half remains with the electromagnetic wave. Battery does work. Now the question is redundant. Resistor hai nahi. So what? The electromagnetic wave will be carrying that energy with it. In the derivation before this we showed to you that if battery does work, the energy that goes into the resistor in the form of electromagnetic energy is I square R dt. What if the resistor don't exist? That energy will be left with the electromagnetic wave. Balance half CV square will go into the capacitor. Beautiful, right?
Yes, sir.
Quick. Just saw the timetable. Tuesday 10:30 to 1:30 we have a lecture. We will be finishing AC circuits in that particular lecture. What I have covered in today's class before electromagnetic waves is there for your JEE mains and advanced. Electromagnetic waves you have got only for your JEE mains. And there is a very strange problem in it. JEE mains mein, if you ask me to set a question paper, JEE main syllabus mein, these concepts are wonderful. But is per question how can I create? This is a concept for the sake of concept. It is a beauty in the subject that you are enjoying. उस पर questions क्या दूँ यार मैं? Do you want me to give E rate at which electric field is changing, A epsilon naught and ask for energy per unit time? Pointing vector per direct formula per questions देना है. Hence my hands are tied. Look at the viewpoint from the examiner's viewpoint. So what will the examiner is told every chapter should get one question at least. Now electromagnetic waves पर क्या दूँ मैं? Correction of Maxwell's relation, Ampere's law. वो theoretical question ही होगा. उस पर problems are very minimal. You cannot give me good problems on this subtopic. So what best do you think I can do to eliminate headache? Frequency range of infrared radiation. What is the frequency range of electromagnetic waves used to cure cancer tissue cells? Now I have taught EM waves, you have studied EM waves, I cannot answer a question from EM waves. Strange, right? That is the practical problem we face in this particular chapter. This is wonderful concept. It completes our theory and understanding of electromagnetic waves. But us par questions cannot be given. So when you refer to your NCERT textbook, after the correction of Maxwell's relation, they did not touch all this concept. They gave you spectrum waves, infrared radiation, wavelength range, frequency range, properties of infrared radiation, ultraviolet properties, X-rays properties. 1.5 sheet of information about the spectrum range is given. Please take a Xerox copy of that, stick it in front of your study place. Every day, X-rays, what is the wavelength range? What are the applications? X-rays बता देंगे आप लोग. Applications of X-rays, bone fracture can be seen because transverse waves can be polarized. Electromagnetic waves are transverse waves. So if there is a thin hairline crack in your bone, when light passes through it, it gets polarized. The thin groove in your bone will be visible on the X-ray sheet. Right? So every electromagnetic wave has its application. Just one page of information from your NCERT textbook. Please memorize that information along with what you know, so that you will be on the safe side as far as electromagnetic theory is concerned. एक और गंदा सा चैप्टर है communications. Right? Communications is information for the sake of information, because we cannot go deep into communications. Right? So that chapter somewhere down the lane, this week I will not be able to do, somewhere down the lane I will complete that for you. Is that clear? Tuesday's class we will be finishing AC circuits. Fine.
Sir, could you please re-explain the resistance?
Re-explain which one?
So the left hand side part. So the diagram.
This one or this one?
So down.
Now, work done by the battery. We showed to you previously in electrical circuits that work done by the battery, half will go into the capacitor, half should be lost in the form of heat. There we told you integral I square R dt will turn out to be half CV square. Mathematically we showed to you. So you are telling me half the amount must be lost in the form of heat. I said yes. What if I don't have a resistor in the circuit? Now my answer is ready. If I don't have a resistor in the circuit, work done by the battery, half the energy goes into the resistor, half the energy goes into the capacitor from the surrounding, using what? Electromagnetic wave. Out of the work done by the battery, half is going into the capacitor, half is lost to the electromagnetic wave. If I don't have a resistor, the electromagnetic wave which is carrying the energy will carry the energy with itself. It will not be going into the resistor. As simple as that. And where did you prove that energy enters the resistor from the surrounding? The derivation before this, we proved to you that energy enters the resistor in the form of electromagnetic wave. Is that clear?
If I have a resistor, all my EMFs will go to the resistor and go to the capacitor.
No, half will go into this, half will go into this. Resistor में I square R dt का ही heat जाएगा, which is half CV square. Right?
So, but no heat is produced in the capacitor.
Heat is always dissipated only in the resistor. We will meet again on Tuesday.